Hello everyone. So this is our first live astronomy event from North Essex Astronomical Society. I'm Ian Lowries and I'm going to be presenting tonight. So what we're going to do is we are going to be taking a look at a few of our nearby galaxies. So what we're actually going to do is find out some interesting facts about them, find out where they are in the sky, and then actually have a look at them through a telescope that we're using from my observatory to actually take some images and show you what they look like for real. So I've been an amateur astronomer for about, I don't know, sort of 20, 30 years now. I recently joined North Essex Astronomical Society, and they're a very friendly bunch of people. We cover the North Essex area, so Braintree, Colchester, Chelmsford and surrounding areas. We always welcome new members, beginners or advanced astronomers, so really anybody who's interested in astronomy is more than welcome to be a member of North Essex Astronomical Society. You can find out more about us at our website, which is www.northessexastro.co.uk. That's www.northessexastro.co.uk. The details are all on our Facebook page, so please take a look if you're interested. So what we're going to do first off is we're going to take a look at the Andromeda galaxy. Now what you can actually see here on my screen is a planetarium view of Andromeda. So where is that in the sky? Well, okay, what we would do normally is we'd get you sort of oriented towards a particular direction. So if you remember where the sun set tonight, roughly southwest, so we're looking west here, round towards south, and if we just look up in the sky, Andromeda is fairly high overhead at the moment. Now the easy way to find Andromeda is if you know where the plough is, then that's the route to finding most things in the northern sky. So we actually turn around and look directly north. So if we've got where the sun set, the west, on our left-hand side, and looking straight ahead we would see north. We then look up, we would actually see the plough. So the plough is something that many people know. It's this kind of shape here where you've got this sort of triangular sort of square of stars with a little handle on it. Now the useful thing about the plough is if we take the two stars on the right hand end here and follow them in a straight line upwards, we come to the pole star, Polaris. Now that's always in the same place in the sky. The whole of the rest of the northern sky rotates around it through the course of the day and night. So if you can find Polaris, you know where north is. Now the plough at the moment is low down, so the constellation we're looking for next is Cassiopeia, which is this sort of M shape or W shape depending on which way it is at a particular time. If the plough is down low, then Cassiopeia is up here quite high. Conversely, in later months in the year, the plough at this time of night will be quite high up and Cassiopeia will be low down. The useful thing about the Cassiopeia is if we imagine it's a W, I know it's upside down on the screen here, but normally we imagine it as a W. If we take this end of the W, the slightly more pointy end, and imagine it's an arrow, and we follow that arrow, we come straight to Andromeda. So Andromeda's near this fairly bright star here. A little bit tricky to sort of orientate it, but so we've got Cassiopeia here, we've got this bright star here. Andromeda is kind of this couple of fainter stars, and it's right there. Now, Andromeda is one of the furthest things away you can actually see with the naked eye. There are a few others if you've got really dark skies that you can see with the naked eye. But without a telescope, this is pretty much as far as anybody can see. Now, viewing it through a pair of binoculars or a small telescope, it's relatively easy to see. It's a small fuzzy patch in the sky. It's about this sort of whole area here is about 3 times the size of the moon. So if you imagine the full moon was sat in the middle here, there'd be another moon and another moon. But you can actually see this middle bit of the fuzzy patch with the naked eye. Even, from relatively light polluted areas just outside town in Essex, you can see it if you know where to look. It's pretty big and it's pretty bright. So what we're going to do now is we're going to switch over and we're actually going to take a look at it. So this is the view right now. outside in my garden from the observatory that I've got set up there. I've got a small telescope, an 80mm telescope, so it's not a huge beast by any stretch of the imagination. It's something you can carry around fairly easily with one hand. That's set up and that's tracking the sky, and we've got a special astronomical camera attached to it. And what we're doing is we're taking exposures of Andromeda right now. So these exposures are taking one about every 30 seconds. So we're taking 30 seconds worth of images. And then what we're doing is we're adding that image to the previous image, and we just keep stacking those up. We call it stacking in astronomy, and that's how we get these fantastic pictures you see on websites and in magazines. On our Facebook page is we actually take lots and lots of pictures. Now, if I was doing one to sort of put on a website or something, I'd be taking exposures of about 5 minutes to 10 minutes, depending on the camera and the object I'm trying to image. For the purposes of this live view today, we're taking 30-second exposures. So every 30 seconds we've taken another exposure, we're adding it to the previous exposures, and then we get a view of Andromeda. So what can we see here? Well, what we can see is a galaxy. So it's a whole huge collection of stars that's outside our galaxy. It's a whole separate, effectively a whole separate city of stars. It's about 2.5 million light years away. Now that means that the light that we're looking at in this image right now left Andromeda about 2.5 million years ago. So to give you an idea, our ancestors at that time, they were little small hairy ape creatures. They'd pretty much just about finished coming down out of the trees, and were starting to walk out of the forests and walk upright, but they were certainly not human at that time. So that's how long ago we're looking in time. So as we look out into space, we look back in time, 2.5 million years ago, no human beings, just little monkey creatures. Now what we can see here, this whole thing here, that is about 1 trillion stars. That's 1,000 million stars. Now Andromeda is a galaxy like our own galaxy, the Milky Way, but it's about twice the size. So our Milky Way is about 400 million stars. Andromeda is 1,000 million stars. Now, one interesting fact that we always like to tell people when we're observing it outside at night is we say that it's actually coming this way pretty quick. So in about 4.5 billion years, it's going to crash into the Milky Way. Or, you know, if you're telling your insurance company, then maybe the Milky Way crashed into Andromeda. But that's quite a long way in the future. That's pretty much right near the end of our own sun's life. But there are many stars in the Milky Way, so we'll still, the galaxy will still be around. Who knows if we'll still be here? But in 4.5 billion years, we'll have this huge cosmic car wreck. Now, one thing I like to think about is how many stars would actually be destroyed if we've got 400 million stars going one way, that's us, and we've got 1,000 million stars coming the other way, that's Andromeda, what we can see here on the screen. How many stars do you think would actually be destroyed when those two things crash into each other? Well, actually, none is the answer. Very, very few, if any at all, would actually crash into each other. And the reason for that is there is so much space between the stars, individual stars, that the two galaxies will pretty much just pass right through each other like ghosts, almost like they're not there. They will just carry on travelling in the direction they've been going for a while, and then gravity will pull them back together again. And after a long period of time of this kind of passing through each other and getting pulled apart and getting pulled back together, they'll merge together into one giant single super galaxy. So, actually what will probably happen is lots more stars will be formed, because when all that sort of gravitational interaction happens, the gas that's inside the galaxies gets stirred up and it starts collapsing to form new stars. And later on we'll be taking a look at another galaxy where that's going on right now. So rather than stars being destroyed, we'll actually get stars being formed as a result of that collision. Now what can we see here? Well, what we can see here is this is the centre of Andromeda. This is what we call the core. It's that big fuzzy ball of stars that all galaxies have. Somewhere in the middle here there will be a supermassive black hole weighing thousands or millions of times the mass of the sun. Can't see it, very, very tiny, but it will be in there. And around the outside we have these spiral arms. Now, as I say, this whole galaxy is about, in terms of how we see it, about 3 times the size of the full moon. So we could plonk the full moon here, we could plonk another one there, and we could put another one there. And if you look at it through a typical telescope, actually mostly what you will see is probably about this much, and the outer reaches you won't see them at all because they just stretch out of the eyepieces field of view. What else can we see? Well, you can see some dust lanes here, and these are part of the spiral arms, which again we'll talk about in a bit. But this is all dark dust and gas that is rotating around the centre of the galaxy, and between them you have the spiral arms. You can see them stretching out on both sides. What we can also see is lots of stars. Now, all of these stars here are actually in our own galaxy, in the Milky Way. They're much, much nearer than Andromeda. It's very hard to see individual stars in Andromeda. But there are a few. So if you look up here, can you see this little patch up in the corner here? Maybe if we can take a look at that. So that there would be, I'll just zoom it in a bit maybe and see if we can a bit closer to it. So this patch that we're looking at here, I'll zoom in a little bit more again. So this bit here, that's what we're talking about. These are actually individual stars. Now these are supermassive blue giants. They're blue supergiants. They're really huge. They're really, really hot. They're burning through their fuel really, really quickly. Now, unlike the sun, which will last about 10 billion years, these blue supergiants, they will only last a few million years because they're so hot and so bright. All of their fuel gets used up very, very quickly, and in a few million years they will blow up in huge supernovas and destroy themselves. But they're so bright that some of these individual dots here that we can see in this fuzzy patch are actually individual stars up to 2.5 million light years away. We'll take another look at that in a different picture in a little bit. So what else can we see here? Well, down there I think we can see maybe there was an aeroplane. That looks like an aeroplane that's just flown through our field of view. You can see the lights flashing on and off and on again, so that's a hazard when you're an astronomer. You often have aeroplanes and satellites zipping through your images. That's one reason why we take lots and lots of individual 5-minute exposures, because if one of them's ruined by an aeroplane, we can join lots of the other ones together and we can actually average out that problem and make it disappear. Whereas if we just took one sort of 3-hour exposure and we had an aeroplane go through it, then it's ruined and we have to throw it away. So that would be a real problem. And in the old days when you used film cameras and you couldn't do this sort of thing with computers, that's exactly the kind of thing that could happen. What else can we see? Well, we can see a couple of other fuzzy blobs. This blob here and this blob here. These are actually other galaxies. So this one here is M32 and this one here is M1110, and they are dwarf galaxies, and they're actually orbiting around Andromeda. So much like the Earth goes around the Sun once a year, every I don't know what the orbital period of these is, but a very, very long period of time, these dwarf galaxies are actually orbiting around the centre of Andromeda, and these are quite large. There'll be 10 or 100 million stars perhaps in a big one of these, but essentially what's happened is they would have been small spiral galaxies possibly originally, but as they've come close to Andromeda and been orbiting around it, most of the outside of these galaxies gets stripped off and just gets pulled off by the gravity of Andromeda and just joins in with the rest of the stars going around it. But the core, this bit here, is really, really dense. There's lots of stars really close together, so it tends to stick together quite well, and then you're left with this these little blobs. And as I say, these are orbiting around Andromeda. Now, the Milky Way has a couple of satellite galaxies called the Magellanic Clouds, the Small Magellanic Cloud and the Large Magellanic Cloud. Unfortunately, you can't see them from the UK. They never rise from here. They're too far south. If you go to the Southern Hemisphere, if you go to Australia or New Zealand or South Africa or South America, you can quite easily see them. Anyway, you can see the Milky Way, so if it's dark enough to see the Milky Way, you'll see the Magellanic Clouds. They look like lumps of the Milky Way that have been ripped off and shoved somewhere further across the sky. Now, unlike these quite well-organised satellite galaxies of Andromeda, our own little satellite galaxies, they're called irregular galaxies. They're a bit of a mess. They're just little clumps of stars, really, and they don't have any particular shape. They're just kind of quite messy, but you can see them. So Andromeda was the first object that was conclusively proved to be outside the Milky Way. Now, back in 1908, a lady called Henrietta Swan Leavitt discovered a particular type of star called a Cepheid variable. Now, as the name suggests, these stars vary in brightness over time. So variable stars get brighter and dimmer over time for various different reasons, but the Cepheid variables have a particular property, which is that how bright they are and how long they take to vary from their maximum brightness to their minimum brightness are linked. So you can tell how bright a Cepheid star is by the period between maximum brightness and minimum brightness, which could be over several days, over several weeks or several months, depending on the star. But if you measure that sort of dimming and brightening over a period of time and sort of average it out, you can actually work out exactly how bright it is. If you then compare how bright it is to how bright it appears in our sky, doing a little bit of maths, you can work out exactly how far away it is. Now that was really useful. And then in 1924, Edwin Hubble, the guy who the Hubble Space Telescope was named after, he identified and measured a number of Cepheid variables in the Andromeda galaxy. Now, at the time, there was a huge debate going on about whether this was part of the Milky Way or whether this was some kind of island universe, as they used to call them in those days, outside the Milky Way. And by finding these Cepheid variables, and again, I think it was a lady, I'm sorry, I don't know her name, who actually did all the hard work, and of course, Hubble claimed all the credit, being a man. He actually it proved that because of the brightness of these Cepheid variables, which you could calculate from their variability, that they had to be outside the Milky Way, and they had to be a long, long way away. Now he got it wrong. He got the distance was about. He said it was about half as far away as it is now, but that's because they actually later on worked out there are two different types of Cepheid variable, and depending on which ones you're measuring, affects how bright they are. But fairly quickly, within about 10 years, I think they'd figured out the true distance, which is about 2.5 million light years away. So this is really a monumental sort of discovery. Before this time, before 1924, we had no idea about the true scale of the universe, and this is really where we started working it out. Okay, so now the images I'm showing you here are black and white because we're using an astronomical camera that actually captures the images in black and white. It's maximum sensitivity. We want all of the light coming in to make sure that we can see the image in near real time, as we're doing here. But you can actually use these cameras to make colour images, but you just need to take a lot more exposures and you need to use colour filters. So what I'm going to do now is I'm going to show you an image that I took with this same telescope and this same camera just before Christmas, and pretty much. So as you can see, the image is in colour. So we've actually used 3 different filters here. Red, green and blue filters, as you might know from sort of mixing paint or projecting images. You can mix the colours together, those 3 colours together, to make any other colour that you like. Pretty much how your TV and your computer monitor will work. And so by taking those, plus we also use quite a lot of the black and white images to actually get the detail in the background. We only need a small amount of colour information. That gives us quite a good sort of representation of the galaxy. So you can see, as we discussed, near the top and the bottom, around the edges, you can see quite a lot of blue. These are the hot blue stars. And then near the centre, we've got a sort of much more orangey colour. This is where the old stars live. So most galaxies, if you look at them, in the same sort of way, then you'll see that the spiral arms is where a lot of the new star formation happens. So the stars tend to be younger and brighter and bluer, and the older stars tend to live in the centre, and they tend to be more orangey, sort of red. So hence the different colours that you see. You can also see a lot of the stars in our own Milky Way, and there are different coloured stars here as well. So we've got some foreground stars, some of the bright stars. You've got some blue stars. Again, these will be relatively hot, and you can see in the background also there's a couple just sort of up and right from the centre. There are a couple of orange carbon stars. These are massive old stars that are really, really, really huge, but very near the end of their lives, and so they're relatively cool. So they appear much more orange in colour. So that's really, kind of the colour image. You can also, as I say, see that we've actually got some sort of other colours in the 2 different satellite galaxies, are slightly different colours as well. Again, depends on the stars that are within them and how old they are. and really that's kind of how you tell the age of a star, and what temperature it is really by looking at how bright it is and what colour it is. We can talk more about that perhaps in a future session. Again, I'll say Andy asked me how come you can see a plane in the live view. Well, we're taking 30 seconds exposures, so what happens is that just like taking a photograph of a car at night, you can see the light streaking along in a long line. Same thing's happening here. The plane just zips through the field of view, and you can see the light stretching out, and then it just gets added to all of the others. So that's Andromeda. Now, what we're going to do next is we're going to take a look at another galaxy. So what I need to do is I need to reposition the telescope and set a few things up. So what we will do first off is we'll tell you what we're going to look at, and we're actually going to look for M33, which is another galaxy. Here it is. This is our planetarium view. Now, to give you an idea of where that is in the sky, it's not far from Andromeda, interestingly enough. It is just so, remember we said we use Cassiopeia, this W in the sky, and we use the right hand half of the W to point to Andromeda, and near it's this bright star. Well, if you take this little bright star here, Andromeda's there. M33, the Triangulum galaxy, is pretty much the same distance on the other side of this bright star. It's a lot harder to see though, it's quite faint compared to Andromeda. It's quite a big galaxy, but it is quite faint compared to Andromeda. So what I'm going to do now is I am going to just do a little bit of repositioning of the telescope. It will take a couple of minutes, so just bear with me. I also need to concentrate, so I may not be able to talk as much as I would like, but just bear with me for 1 minute. Connected, yes we are. Over we now. Okay, so this will take a minute or two to actually find the star, so we'll just let the software do its stuff. And as I say, here we have Triangulum. Now, Triangulum is, as I say, it's another spiral galaxy. It's the second large member of our local group of galaxies. So in the local group, there are about 54 galaxies. Andromeda's the biggest, then the Milky Way, then we have Triangulum. So hopefully we're just getting there. The software is finding its way to the star that we wanted. Yeah, success, done. Now I just need to start exposing. Hopefully nothing will crash. Yeah, good. Oh, right, get rid of that. Bring that one back. Here are stacking. Exposing. Right, so we're going to wait a minute or two, and hopefully, as I say, we should get our first image. What I will do is I will actually show you what happens. At the moment, we've still got the image of Andromeda that we took a picture of earlier on. Now it's exposing for 30 seconds, so in 30 seconds we'll get another image, and first off it will probably appear quite unimpressive and black, and I will then need to adjust the brightness of the image to actually allow us to see it, so just bear with us. Okay, so you've got something there. Again, you can kind of see something starting to appear, and actually nicely on this image we've nicely got another plane. I think this is probably a satellite actually zipping through because it's not flashing on or off, but this line here is, again, it's a satellite that's flown through the first exposure that we took. Again, occupational hazard for astro imagers, planes, satellites, neighbour security lights, whatever you like, anything that can go wrong will go wrong. So second exposure's come in now, and you can see it's starting to get a bit clearer. I won't adjust the brightness just yet, but you can start to see already, here we have the core of M33, the Triangulum galaxy, and you can start to see the spiral arms appearing. Now this time we're looking at a more favourable angle. We're still not looking straight down at it, we're still looking at a bit of an angle, but it's not as steep as with Andromeda, so it appears more circular. The spiral arms are a bit more obvious. So we start just trying to adjust the brightness a little bit here. Happens not too far, back a bit. And this one, as I say, this one is quite a bit fainter than Andromeda, so seeing it is a little bit tricky. Out there we go, that's much better. Now it looks quite lumpy, this image. I mean, the background is quite fuzzy and blobby, but that's just a function of taking images with these kind of cameras in low light conditions. We get a lot of noise, so we get a lot of sort of speckles. If you get your sort of iPhone or your Android phone out and take a photograph without the flash in a dark nightclub or whenever you like to spend your time, you get the same sort of effect. You'll see there's lots of sort of speckly noise appears all over the image. And that's simply because there's not enough light coming in to really get a true idea of what the background is like. But really the foreground here is quite clear, and you can actually see, as I say, these blobs, these sort of bigger blobs appearing in the centre of it here. They are not noise, they are actually a feature of this galaxy. It's got quite a lot of star forming regions. We'll take a look at a picture of it later on. As I say, again, you can see these spiral arms stretching out around the sides here. So Triangulum, as I say, there are about 54 galaxies in what we call the local group. That's kind of our neighbourhood. So, in galaxy terms, I guess, somewhere between here and sort of here in the shops, we've got three big galaxies. We've got Milky Way, which is in the middle, about 400 million stars. We've got Andromeda, which has got about 1,000 million stars in there. And in the Triangulum galaxy, we've got about 40 million stars. So it's about a tenth of the size of the Milky Way. It is actually quite small, but it is also one of the larger galaxies in the local group. The rest of the 51 galaxies in the local group are all very small dwarf galaxies, the kind of stuff that we were talking about before. So things like the Magellanic Clouds that are actually orbiting around the Milky Way, and the M32 and M1110 orbiting around Andromeda. There are lots of other little galaxies like that floating about between us. Now what you can see has happened here is actually the stars are getting a bit of a funny shape on them, and I can tell you that's because it's quite windy outside tonight, so the telescope has obviously caught a little gust of wind and it's been shaken backwards and forwards during an exposure. So what I'll actually do is, if I reset the stacking and start again, we'll go back to the first image and we'll actually just see if we can get it to build up again more nicely. Again, unfortunately, on a night like this, nice clear weather, but it is pretty windy. So Triangulum, say about 40 billion stars, about the tenth size of the Milky Way. Now, as you may know, with galaxies, all of the stars actually orbit around the centre of the galaxy, so they're kind of going around this way in this case. Again, so we've kind of lost it a little bit there, but we just need to wait for it to build up with a couple of exposures. The stars are orbiting around the centre, very much as I say, like the Earth goes around the Sun, like the other planets go around the Sun. The Sun orbits around the centre of the Milky Way, and in all galaxies, all of the stars are orbiting around the centre. But you can see that we've got these spiral arms. Now, there's a bit of a problem with this if you think about it. The stars around the outside of the galaxy, any galaxy, will take much, much longer to go around than the stars near the middle. So, the same way that the Earth goes around the Sun once a year, but the outer planets can take tens of years to go around. Same thing's happening with the stars in a galaxy. They go around the centre quickly. The ones out on the outside take a lot longer to go around. But there are these spiral arms. Why would they be there? Because if these stars are moving quickly and these stars are moving slowly, then what would happen is that these spiral arms very quickly sort of wind themselves up, a bit like if you're kind of winding up a sort of extension cord or something onto a reel. The spiral arms would wind up and then very, very quickly break up, and you wouldn't see any spiral arms. So what is going on? What they clearly don't do that, because lots of galaxies that we're looking at have spiral arms, so there must be something else going on. Well, the thing to realise is that these aren't solid objects. They're not like the sails on a windmill, or the little sort of bits on a child's toy windmill. They're not solid objects at all. If you've ever been on the motorway, so if you've gone the M25, we've all been there, you're driving along quite happily at 60 or 70 miles an hour, and then suddenly the traffic starts to slow down, and you find yourself stuck in the back of a traffic jam, then you're crawling along for a mile or two, very, very slowly, and then suddenly it clears and you speed up again and you're doing 60 or 70 miles an hour again, and there was nothing there. There was no broken down car, there was no road works, there was no apparent reason for it, and you're sailing along thinking, great, I'm through that, and then a couple of miles down the road, same thing happens again. You slow down and you hit the back of a traffic jam, you crawl through the traffic jam, you whip to the front of it and you zip out and start speeding along again, and again there's nothing there. Now, all that's happening there really is it's just down to the sheer volume of the cars, and what happens is that somebody touches their brake a bit quickly somewhere along the motorway, the next person behind them brakes a bit harder, the next person behind them brakes a bit harder, and because there are so many cars close together, they all start slowing down, and these phantom traffic jams create themselves, and they're a bit like they're a bit like waves, really, sort of compression waves. So what happens is the individual cars are moving along the motorway, but the actual clumps of free-flowing and traffic jam kind of stay in the same place, or they migrate slowly backwards down the motorway. And exactly the same thing is happening here in this spiral galaxy. The individual stars are zipping around at whatever speed they need to be going at to maintain their orbit, but they get into these density waves effectively. So as they come into the start of the spiral arm, the density builds up, you get lots and lots of stars, and then they come out the front into an empty space, and they spread out and they compact and they spread out, and so the spiral arms stay where they are or just move very, very slowly, but the individual stars zip through them. So if you're in a spiral arm, you don't stay in it, you come in from the back, you go through it, they disappear out the front, and you carry on and you go into the next spiral arm, and so on. So that's really what's going on there. It's not a sort of solid object, it's actually about how many stars there are. So, okay, I'm going to quickly shoot over to another image here. So again, I'll just need to adjust the sound on this. I think I know what happened, why I disappeared last time. But if we switch across to another scene here, I'll just see if I can. Okay, so hopefully this time you can hear me talking. It might be a little bit loud. So what we have here is, again, it's an image. This has been taken by another member of North Essex Astronomical Society, Alec Alden. This is an image of M33 that's been taken through his camera. The orientation is slightly different, so it's a bit flipped over compared to the image I'm showing you on my camera. But again, you can see it in colour. You can see the spiral arms really, really clearly. Now, one of the things you'll see in there, if you look closely around some of the spiral arms, there are some quite bright red little blobs in there. Now these are really interesting. These are regions where there's lots and lots of hydrogen gas. Now stars are made from hydrogen gas, and as the spiral process continues, what happens is these clumps of gas get compressed and heated up, and then some of it cools down and it collapses, and that's where new stars will form. Now we have similar regions in our own galaxy. So if you look at the Orion Nebula, which is something again we can show you through our telescopes, that's a star-forming region made of lots of hydrogen gas. If you're looking from outside the galaxy, down on it, you would see something very similar to this sort of these little red blobs that appear around the spiral arms. So again, we'll just switch back to the live view here. And as I say, that is, as I say, these little blobs in red are the hydrogen gas areas. Okay, so now before we move on to the next galaxy, I'll just tell you a few things that we are doing. So we're running a number of public events this month. First up, we have on Wednesday the 17th of January from 7:30 PM till 9:30 PM a telescope help and astronomy question and answer session. That will be at the Henry Dixon Hall, Rivenhall end. That's just off the A12 near Whittam. So if you know where the Empire Diner is on the A12, it's literally right behind there. If you just come off at the Rivenhall end junction, it's about a minute or so from there. But again, check our website for details of how to get there. The session is open to everyone. We know at this time of year that lots of people have perhaps got a new telescope or are looking for a new hobby for for their New Year's resolution. So we will run a session where you can come along, bring your telescope. We'll help you to figure out how to set it up and how to use it. If the sky's clear, we can obviously set it up outside in the car park, but if it's not, we'll still run the session indoors. A number of our members will be there, so if you've got any questions about astronomy, we can try and answer them. If you're interested in becoming a member, you can meet us and find out more. So please do come along. It's a fairly informal and fun session, so just drop in and we'll have a chat. Then coming up on Saturday the 20th of January from 6 p.m. till 10 p.m, we've got stargazing at Great Notley Country Park. For those of you who come along regularly, notice that we've got extended hours this month as a bit of a one-off. I think we've got the same next month till 10 p.m. Normally we finish at 9 p.m. We're hoping that the cafe is also going to be open. That's a free session, so there's no need to book, just turn up on the nights, anytime between those two times. Please note you will have to pay the normal car parking charges to the country park, but as I say, the telescope session itself is free. We'll be near the sky ropes behind the main Discovery Centre. Obviously, again, this session depends on the weather, really. If it's cloudy, we will still be there, but we'll actually be indoors. Hopefully we'll have a room set up there where we can, again, talk to you about telescopes, show you some of our equipment, and show you some of our images. So if you're interested, do come along. Please check our Facebook page or our Twitter account on the day to check what the status of the weather is, and of course wrap up warmly because it's always very cold outside at this time of year, whatever the weather. And finally, this month on Saturday the 27th of January from 6:30 p.m. to 9:30 p.m, we've got stargazing at Abberton Reservoir with Essex Wildlife Trust. The session will run whatever the weather, but booking is essential, so you need to go to the Essex Wildlife Trust website, that's essexwt.org.uk, check their What's On section, and that will give you the details of how to book the session. There are a limited number of places, so if you're really interested in coming along, then please book early, because these events quite often sell out. Again, the visitor centre will be open, they'll have snacks and hot food available. If the weather is good, again, we'll have our telescope set up outside and we can show you some of the things that you've seen tonight, as well as many other things. If the weather isn't brilliant, then we'll still be there. We'll have some indoor displays, and members of the society will be doing talks through the evening about different subjects. Unfortunately, you won't get to see my lovely face in person at that particular event, because I'm afraid I can't be there, and I hope to see you at the other events. Again, all details on our Facebook page and on our website, so please do check for more information. So what we're going to do now is we're going to see if we can find another galaxy. So what we've seen so far are some pretty big galaxies, but what we're going to try and find now is we're going to try and find a much smaller one. It's not small in terms of size, but it is small in terms of what we can actually see, because it's quite a long way away. What I will do is I'll find it for you. So again, if we find out where it is in the sky, we're going to look at M74, which is another galaxy in the sky. So again, it's a spiral galaxy, and this one we're actually looking straight down on it. So although it's not very big and it's not brilliant for us astronomers, amateur astronomers, if you're a professional astronomer studying spiral galaxies, it's absolutely brilliant, because you're pretty much looking straight onto it from above. And where is it in the sky? Well, it's a bit lower down, but again, if you found Andromeda and you found Triangulum, which is at this time of year, it's just sort of below it. You keep coming down to M74. It's much lower down. It can be seen with a telescope, but it's a bit harder to find. So again, I'm now going to switch over and just spend a minute or two trying to find it. If you just bear with me. So just give me a minute or two as I work the technology here. Okay, so if we go to that one, bear with me a minute or two. So again, this is going to take a minute or two to happen. So what we're having to do here is I've got some software running on, let's show you actually, let's show it's going, running some software which I've put all the different things that we want to see into, found where they are in the sky. I've then told the software to point the telescope at that object. What it's then doing is it's then taking an image of that area of the sky, and it's using some clever software to work out where exactly it's looking in the sky, because telescope mounts are not very accurate. They'll get you close to an object, but they won't get you completely 100% on it. So we use some software that actually takes a picture, works out what it can see, and figures out how accurately it's looking at it. And if it's not pointing in the right place, it'll just move the telescope a bit to where it should be, take another picture, and then confirm it. So that's great. So we've done that, and now we will switch back to our live view software, and we will take another exposure. So I'm going to reset that. I'm going to start exposing, and again we're going to take 30-second exposures. Now this one will be a lot smaller. It's not a huge galaxy by any stretch of the imagination. So if I kind of show you again in the planetarium view, that's M74 there. It is much smaller than Andromeda, or see, Andromeda is about 3 times the size of the Moon. M74 much smaller. It's probably I would say about a quarter of the distance across the Moon, if that, in terms of size. Right, okay, so we've got something appearing now. I'll just bring it up. Again, we've got one exposure here. This is not super bright. It's a lot smaller, but again, you can kind of see the spiral arms starting to appear here. So we just wait a minute or two for the image to build up. Again, you can kind of see on what I will do on this one, I think, is I'll zoom in a bit because it is so small. But you can definitely see, so there's the core, here are the spiral arms, and again, this is kind of looking straight down on it. Now, this isn't exactly what the Milky Way would look like, but if we were above the Milky Way, it would look very similar. You see these spiral arms, and you see these dark areas, and you see the bright centre. But the Milky Way and Andromeda are what we call barred spirals. So rather than having a really circular centre, they actually have quite a long, bright sort of thing looking a bit like a sort of bar, like a line effectively in the centre. So this one, as I say, is, let's see if we can make it a bit brighter for you. Make it a little bit. Yeah, so you can just start to see some of the lumps and bumps appearing here. As I say, M74 is a lot smaller. Now, what do we know about M74? Well, it's 32 million light years away. So Andromeda was 2.5 million light years away. Triangulum was 3 million light years away. M74 is 10 times further away than Triangulum, so it's 32 million light years away. So we're really getting back into the distant past now. So we're pretty much halfway back to when the dinosaurs roamed the Earth. The light appearing from this galaxy here. So dinosaurs were about 65 million years ago. So this is about 32 million years ago. So about halfway. And as I say, it's got nice spiral structure. So professional astronomers love it. Again, you can see we've got some sort of double stars appearing here because it's a bit windy out there tonight. Now, it's made up of about 100 billion stars, so it's somewhere between the Milky Way and Triangulum in terms of size. So Triangulum about 40 billion stars, Milky Way about 400 billion stars, M74 about 100 billion stars. So it's not a huge galaxy, but it is relatively large. And as I say, it's a good one to look at because it's kind of gives you that nice top-down view of the stars. Okay, so right, we're going to look at one final set of galaxies tonight before we finish up, and it's going to be a good one. We're going to give you 2 for the price of 1. So we just, again, if you just bear with me a second, what we will do is we're going to find the galaxies that we're looking at. Now, these are on the other side of the sky, so these are actually quite near sort of near the pole. So if I just find it for you, so find M81. In the box, that would help, wouldn't it? 81, there we go. So we've zipped across the sky. What we have here is we have M81, which is this one here, and we also have M82, which is another galaxy very close to it. Now, they are actually quite close together. We'll find out some more about them in a minute. But if you want to know where they are in the sky, remember we were talking about finding the plough here. So remember, this is the shape of the plough. We've got the handle of the plough, and if we then zip up, we've got the pole star, so pretty much due north there, and then M81 and M82 are just up and to the right here at this time of night. Obviously they'll be in different places. Cloud goes around, but again, if you find 2 pointers and the line up to Polaris, just to the left of that line there's a star, the line of stars, and just to the right of that line is where these two are. So again, I'm going to try and find them for you. Just bear with me a minute or two. Again, I will set my software off to find this. So just the same as we did before, we are going to connect up the camera to this software. Go to it. So just bear with me a minute. And this will take a minute or two, so I can show you what's going on here. Telescope is in the process of moving, so this bit of software here is actually driving the telescope, and when it's finished moving, see these numbers changing. This is the telescope zipping across the sky. As soon as it finishes moving, it will tell the other bit of software that it thinks it's pointing to the right bit of sky to show us M81 and M82. Quite a long way to go, so it's got to zip quite a long way around the sky. Yeah, we've got there, so now we've taken a picture, and again, our clever software is now trying to work out, are we pointing at the right bit of the sky or not? And of course, the first time we won't be, we're not quite where we want to be, so we move the telescope a bit, we take another picture, and we validate it, we check it, and again, our software is figuring it out, and this time we're successful, so we say done. Again, we can see that got it here. Now if we switch over to our live viewing software, bear with me a second. Up. We reset, start exposing. Again, so we need to wait 30 seconds to get our first image. Again, if you're looking at this image of M81, sort of M74, again, you can see these lovely little line of dots here. This is a plane that's zipped through the field of view again, probably, or it might be a satellite that's spinning around and reflecting the sun at this time of night, but I think it's probably more likely to be a plane. Hard to know though without sort of really checking it out, but bear with us a minute and we'll get our first exposure coming up of M81 and M82. There we go. Right, so now I'm going to adjust brightness a bit. Quite so overexposed. There. Bit. Again, so if we just wait a minute or two, so we've got a couple of images, we'll actually be a bit brighter and look a bit better, so just bear with me a second. There we go, so we've now got 2 exposures. Now we've got 2 galaxies for the price of 1. So this is M81, and again this is a spiral galaxy like the ones we've been talking about. Again, we're looking at it sort of, it's a different angle on the screen, but it's very similar to Andromeda. So we kind of, again, if you imagine a galaxy being a circle, it's kind of tipped over a bit, and we're looking at it edge on. Again, you can see the bright central core of the galaxy. You can see the spiral arms whipping out around both sides. Now, M82, so M81 is called Bode's Nebula after the chap who discovered it. And this is what we call the Cigar Galaxy. Now, this is another spiral galaxy. But this time, instead of looking at it straight on or at an angle, we're actually looking at it completely edgewise. So my hand that way to match the object. So you imagine it's being tipped right over and tilted up this way. A bit hard to do this thing. You're actually looking at the edge of the galaxy, so we can't see the spiral arm because we're looking along it. Now it looks a bit weird, this one, and it is a bit weird, and I'll explain why in a minute or two. So M81, this one here, is about 12 million light years away, and so actually is M82. They are very close together. They are actually both 12 million light years away. They are actually interacting with each other gravitationally, a bit like we're being pulled towards Andromeda, and Andromeda's being pulled towards us. These two have actually already had a bit of a brush with death, as it were. And actually over here we have a third galaxy. It's a much smaller one. So this little fuzzy patch here. This is NGC 3077. Unfortunately, once we got out to the sort of the 18th and 19th centuries, the golden age of discovering stuff in the sky, and it all started becoming a bit more sort of mathematical, and in latter days, computerized. Things don't get nice names like the Cigar Galaxy and stuff like that. They just get given numbers. This is the New Galactic Catalogue, which is actually not that new. It's pretty old, because these are quite bright galaxies and were pretty easy to find back in the early days, but they were all given numbers because there are so many more of them. There are only a few very bright objects that you can see relatively easily, and once you need to start getting serious with a telescope kit to see this kind of stuff. But these three galaxies are all about the same distance away from us, and say 12 million light years away, and they're actually interacting with each other. Now, the one that's been affected most is actually M82, the Cigar Galaxy. And if we take I'll just zip over, so we've zoomed in a bit here. If I'll get a bit closer to it again, so you can take a little bit of a look. Quite hard to see, but if you look at it, can you see it's quite lumpy here? There's a lot of dust, a bit like the dust lanes that we've got in the Milky Way and the dust lanes you saw in Andromeda, but they're not going in nice, neat lines around the middle of the galaxy. They're all sort of pulled up and down. And if you had a slightly better image, which I don't have here, unfortunately, this one's not brilliant, you'd actually see there are whole massive tendrils of gas coming out above and below in all directions from M81, M82. And the reason for that is that interaction with the other two galaxies. So I'm just checking some questions I'm getting here. Yeah, I'm using an ED80 telescope. For those of you who are interested, it's an 80mm telescope. It's not some massive beast of a telescope like you might see on all those lovely astronomy programs on TV. So you could quite happily pick this up and carry it around with one hand. So yeah, if anybody's interested, of course we can talk to you about telescopes and how to do this kind of stuff. But mainly you just have to have a very forgiving wife who will let you have more than one telescope. I think we're on 1 in, 1 out in this house now. We've reached 6, but I'm always hopeful of an extra one. So anyway, back to M82. It's what we call a starburst galaxy. So it's been so interesting. It's been so affected by interactions with the other two galaxies, M82 and M82 and the M81 NGC 3077, that it's actually been really stirred up, and loads of gas has been stirred up in the middle of it, and it's now forming loads and loads of new stars very, very rapidly. It's called, and there are a number of these galaxies known through different parts of the sky, but this is probably one of the most well known. It really looks like it's almost exploded when you see it in a nice color image. Now what's happening here is that these huge numbers of stars are being formed, and again, they're like the ones we looked at in Andromeda, those blue supergiants. They're all really massive stars, have very, very short lifespans. They only live a few million years, and on average in M82, one of them will go supernova about once every 10 years, and that's blasting out more material and stirring up more gas and creating lots more new stars and heating everything up. So it's a pretty crazy place to be, really. If you were there, it would be quite an exciting galaxy to live in, but I wouldn't like to get insurance on my planet, I'll put it that way, because it's pretty hot under the collar there. Now I've got an image of this taken by another member, so again I'll just switch over to that. Now this image here was taken by another one of our members, Paul Blakesley. Now he took this with his telescope, his refractor, and he used a DSLR camera. Now this is a relatively short exposure, so you don't need, again, these galaxies are quite bright, so you don't need to take huge long exposures to get some of these. Again, you can kind of see the spiral structure of M81. And if you look closely here in M82, you can see there's quite some red patches here. This is all that gas we were talking about that's been stirred up in this big explosion. It's all kind of streaming out above and below, and if you've got like a sort of professional observatory photograph, then you'll see there's big tendrils of it coming all the way around. So again, what we have is three galaxies for the price of one, as I said. So if I bring it back up again, zoom out, you can see, as I say, M81, M82, and NGC. I can't remember these numbers. 3077. And doubtless, every time I take an image, I put it through some software to figure out what else I've got in there. And there are lots and lots of stars in here, obviously, but doubtless some of these other little lumps and bumps in the background, these will also be galaxies. So I'll give you an example. Should we nip back to our Andromeda image? Just bear with me a second. Look down in the corner here, you may be able to see there's just a tiny, in the bottom left corner, can't really point at it, but right down in the bottom left corner you may well see a little fuzzy blob. That's actually a little galaxy in the background. And every time we take one of these images, if we run it through a process to check what we've got, you'll find there are probably half a dozen or more galaxies, sometimes tens of galaxies, depending on where you're pointing in the sky. So that's it, really. As I say, I think hopefully you found it interesting. Hopefully we've managed to not have too many technical problems tonight. It's gone relatively well. The weather's been quite kind to us. If you are really interested in astronomy, we'd love to see you at one of our events. As I've said, we've got those events. And next month, so we've got some, as I say, some stargazing this month. We've got what's called a public meeting this month, and then we'll have similar sort of events again next month. So again, please do come along if you're interested. Thank you very much for watching. I hope you enjoyed it, and as I say, keep your eyes peeled. We'll run another one of these events as soon as we have some good weather. Thank you for watching.